Statistics Lesson 8.3, Testing a Claim about a Mean. Objectives. Develop the ability to use sample data to conduct a formal hypothesis test of a claim about a population mean. Here are the components that should be included in a hypothesis test. Statement of the null and alternate hypothesis expressed in symbolic form. Value of the test statistics. Selection of the sampling distribution to be used for the hypothesis test. Identification of a p-value and or critical value or values. Statement of a conclusion, rejecting the null hypothesis or failing to reject the null hypothesis. Statement of a final conclusion that uses simple and non-technical terms to address the original claim. Testing claims about a population mean with sigma not known, which is the way you will find it most times. Objective, use a formal hypothesis test to test a claim about a population mean. Notation, N is the sample size. S is the sample standard deviation. X bar is the sample mean, and mu sub x bar is the population mean. Requirement. The sample is a simple random sample, and either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. The statistic we will use is the student t distribution. All right. If the standard deviation is known, then you will use the z. But if it is not known, you will use the the student t distribution. And the test statistic is t equals x bar minus mu sub x bar divided by s over the square root of n. Requirement of normality, or n is greater than 30. The t-test is robust against a departure from normality, meaning that the test works reasonably well if the departure from normality is not too extreme. Okay? In other words, if the population is not itself normally distributed, use the condition n is greater than 30 for justifying its use. And we've learned in the past normal probability stuff like that to test if it is normal. Properties of the student t distribution. The student t distribution is different for different sample sizes. The student t distribution has the same general bell shape as the standard normal distribution. Its wider shape reflects the greater variability that is expected when S is used to estimate sigma. In other words, when the sample standard deviation is used to estimate for the population standard deviation. The student t distribution has a mean of t equals 0. The standard deviation of the student t-distribution varies with the sample size and is greater than 1. As the sample size n gets larger, the student t-distribution gets closer to the standard normal distribution. Example, sometimes of sleep for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times hours are listed below. Here are the unrounded statistics for the sample. N equals 12, X bar equals 6.83 repeating hours. Standard deviation S is 1.9924094 hours. A common recommendation is that adults sleep between 7 and 9 hours each night. Use the p-value method with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. Okay, so let's do that. Let's do that. One, let's see, what did it say? It said identify sleep less than 7 hours. So step one, mu is less than 7. Now, the requirements, I just about forgot about this. The sample is a simple random sample. The second requirement is that population is normally distributed or n is greater than 30. The sample size is n equals 12, which does not exceed 30. So we must determine whether the sample data appear to be from a normally distributed population. Okay, and let's do that real quick. So we're going to go in here and menu, new document, no, and then lists and spreadsheets, and we'll just call this AA. All right, and then let's go down and we'll type those in. 4, 8, 4, 4, 8, 6, 9, 7, 7, 10, 7, and 8. All right. So next, we'll press on, and we'll go here to graph, and we'll hit AA. All right. Now let's go to menu, plot type, for normal probability. Okay. The normal quartile plot, it looks to be approximately normal. I don't really see any outliers or anything like that. So we're going to say it's normal. I was kind of thinking about that. That's not too bad. I'm not seeing a pattern. You know, it's not like this or nothing like that. I'm not really seeing a pattern. So we're gonna say it is approximately normal. So all right, number one, U is less than 7. Number two, U is greater than or equal to 7, the opposite, okay? And then 3, what are our test statistics? Well, let's see, we're going to have our null hypothesis is going to be mu equals 7, okay? And our alternate hypothesis is going to be mu is less than 7. Now that's our original claim. Okay, that's our original claim. Or that's the original claim. Step 4, alpha is 0.05. Okay, and we are going to use the t-distribution. Now here is where it's going to kind of, let's split a little bit. Let's see. We've got N is 12, X bars, and S is, okay, we got all of those. And we know we're going to use the T distribution. So we got T equals X bar minus mu sub X bar over S divided by the square root of N. Now, if we're going to do the p-value, we don't actually have to solve this just yet, okay? And I'll show you. Let's do the p-value test. So we're going to go back to this right here, and then the first thing we're going to do is menu 411. Number of lists is 1. X list, we call it AA, and there we go. And then we can check 1.9. 41. Okay, it rounded right there. But if you click on it, it doesn't round. See, you know, that doesn't round. All right. And then we can kind of, it gives you a few things. All right, good. We got that. Now, there's a couple ways we can go from here. I'm going to show you a nice, easy one. All right, let's go menu. And then we're going to do 4 for statistics, 4 for stats test, and then 2 for t-test. We put the data in, so let's just use the data. All right, and we've got mu 7, okay, and then our list is AA. And here we said, well, let's see, the frequency list. We said it was less than 7, right? Our alternate hypothesis is less than 7. All right, we'll just put it in the D thing, and then we'll click enter. Aha, p-value is 0.388689. All right, so we'll put that over here. P-value is 0.3886, and it just keeps, but that's enough. That's enough. All right, and what do we know? Well, we know our p-value is greater than 0.05. Okay, so 7, we're going to fail to reject the null hypothesis, and then 8. And you know, let's draw right here. So this is less than, so we have a left-held test, right? And right here, this would be alpha equals 0.05. And this p-value is going to be over here at 0.3886. So that's why we're not rejected, okay? So we conclude that there is not sufficient evidence to support the claim that the mean amount of sleep is less than 7 hours. All right, and there we go. Now that's for the p-value, okay? What about the critical value method? So let's see here. I'm just gonna put a little, let me put a little thing right here, and we'll just kind of cover that up. Okay, and we'll do the critical value method. All right, now this time we're going to have to calculate that right there. So, well, we already have. Let's see here. We did and let's see. We've got everything we need right here. Okay. So let's calculate our z value. First, let's go here and let's get our t value. And we're going to do menu 656, and the area is going to be 0.05. Our degrees of freedom are going to be 11, and we hit enter, and we got negative 1.796. So let's draw our thing here. This is for our student t distribution. And we got over here somewhere negative 1.796. All right. So we need to find our t value here. So t equals, and then we got, what is that? 6.83333, 1, 2, 3, 4, 5, 6, 7 minus 7 over 1.9924094 over the square root of 12. Yeah, that doesn't look like 12. Over the square root of 12. That's 992.4. That's a 4. I erased it by accident. Okay, so let's put that in the calculator. And control divide. We got 1.87 of those minus 7. And that was supposed to be 6, not 1. 6. All right. And then on the bottom, control divide. We got 1.9924094 over the square root of 12. And it's negative 0.2897. So I'm going to say that is negative 0.290. Okay, so that's going to be over here somewhere. All right, this being 0, that's going to be over there, negative 0.290. So we reached the same conclusion. We reached the exact same conclusion. We failed to reject the null hypothesis because it's not over here in the critical region. It's not over there in the critical region. So we fail to reject it. And we conclude that there is not sufficient evidence to support the claim that the mean amount of sleep is less than 7 hours. Good deal. Now, I think there's one more we need to try. We need to try the confidence interval method, the third method. And let's call this the confidence interval method. And what do we got here? So we're going to use a 90% confidence interval. So let's go to our calculator. Menu 662. And let's see here. I think menu 6, 6, and then 2 for the t interval. All right, we can still use the data. Let's just hit OK. And the list is AA. It's not going to do it like that. All right. Why is that not working? Let's type in AA and see if it doesn't seem to be. Nah, that's not going to work. Well, we can go and we'll just do the stats there. Okay, data X bar. Well, what is our X bar? And that is 6.6.8. Oh, I didn't. 1, 2, 3, 4, 5, 6, 7, and then that's 1.99240.984. N is 12, and our confidence level is 90. And there we go, 5.8 to 7.86. So let's see here, 5.8. So our confidence level is 5.8. 0.004 is less than t is less than 7.866. I think it was 3. 7 is contained in this interval. Okay, 7 is contained in that interval. So we fail to reject the null hypothesis, and we can conclude that there is not sufficient evidence to support the claim that the mean amount of sleep is less than 7 hours. Now I want to show you something else. I didn't actually have to do it there. I could have done it right here. So we got this right here. We'll go menu, and we got 4 and confident 402. Oh, that was 3, 432, and then data. And then we could have used AA and then change this to 0.90. And what do we get? Yeah, we'll ride over that. There we go. And what do we got? 5.8 to 7. See? Nice and easy. Okay, nice and easy. Good deal. Good deal. All right. Data, another example. Data set 3, body temperatures, includes measured body temperatures with these statistics for 12 a.m. on day 2. N equals 106. X bar equals 98.2 degrees Fahrenheit. The standard deviation is 0.62 degrees Fahrenheit, and we're going to use an alpha of 0.05 significance level to test the common belief that the population mean is 98.6 degrees. So let's see here. Mu equals 98.6 degrees Fahrenheit. Okay. 2, is not equal to 98.6 degrees Fahrenheit. Step 3, the null hypothesis is 98.6 degrees Fahrenheit. And the alternate hypothesis, and remember, this is our original claim here. Original claim. That's our original claim. And we got, I didn't write that quite right. I got mu equals 98.6 degrees Fahrenheit. You don't know how hard it is for me to turn that F around like that. I hope y'all appreciate that. Mu is not equal to 98.6 degrees Fahrenheit. 4, our alpha is 0.05. 5, we're going to use the sample mean x bar. So we'll use the t-distribution because the standard deviation is not known. So 6, we're going to have t equals x bar minus mu sub x bar over s divided by the square root of n. All right. And we'll just go ahead and fill this out. 98.2 minus 98.6 divided by 0.62 over the square root of 106. All right. So let's do, we'll do the p-value method. P-value method. P-value method. All right, so let's go to our calculator. I'm going to clear this out. And let's just go to calculate. We'll do it old-fashioned way. Menu 6, 7, 2. Data method, we'll use stats. All right. And what do we got? Well, that's going to be 98.6. Our x bar is 98.2. Our standard deviation is 0.62. N is 106. And our alternate hypothesis is not equal to 0. So we click OK, and we get a p-value. Whoa. So let's do that. Let's write that p-value. That is p-value equals 0.12345678, and then it's 1403. 1403, and I think that was 69, but you get the point. All right. I think that is definitely, p-value is definitely less than 0.05. Okay. It's definitely less than 0.5. So I'm going to come over here, and that was 6. I'm going to come over here and say 7. We're going to reject the null hypothesis. And we're going to state 8 that there is sufficient evidence to warrant rejection of the common belief that the population mean is 98.6 degrees Fahrenheit. All right. So that was a p-value method. Easy peasy. What about, well, let's see here. What about, let's try the critical value method. Critical value method. And let's see. Let's go to our trusty rusty calculator, and we're going to type in menu 656. And oh, I need to show you something. All right, we're doing, let's see here. Okay. So our alpha is 0.05, but this time we're doing a two-tailed test, right? So 1 minus, we're going to have 95% here in the middle, and over here we're going to split that. That's going to be 0.025, and 0.025. Okay, so now that we got that, let's go back to here. Our area is going to be 0.025. Our degrees of freedom is going to be 105. Press enter. And we got negative 1.9828. So we'll say negative 1.983. Now this one over here is going to be 1.983. But if you like, we can test it. All right, 95 plus 0.025 is going to be 0.975. So let's see here. Menu 6, 5, and then 6. Area 0.975. Our degrees of freedom is 105. And we got 1 point. There we go. Okay, so, oops. One of those two there. All right. Now we need to calculate our t value. And we got that right there. And let's see here. It is going to be, let's see here. We've got control divide. We got 98.2 minus 98.6. Control divide. And we got 0.62. And the square root of 106, and I get negative 6.64. So I got something way out here. All right, negative 6.64. Okay, so again, we're going to reject the null hypothesis and say there is sufficient evidence to warrant rejection of the common belief that the population mean is 98.6 degrees. Cool. Last method there is the confidence interval. All right. Confidence interval. Confidence interval. All right. And this is pretty easy. We'll go in here and menu 6, 6, and 2. And we'll use stats. All right. And X bar 98.2. And S is 0.62, N is 106, and we're going to do a 95% confidence level. All right, what did we get? We got 98.08 to 98.31932. So the confidence interval is going to be 98.08 is less than t is less than 98.32. 98.6 falls over here, okay, is not inside the interval. So again, we'll reject the null hypothesis and state there is sufficient evidence to warrant rejection of the common belief that the population mean is 98.6 degrees. All right. Let's see here. Testing a claim about the mean when the standard deviation is known. Okay, we will test. We will use the following. We will use the previous method, but use z instead of t. Okay, we'll use z instead of t. Notice the only real difference here is we're using the standard deviation. Okay, so that makes it the z value. Probably not going to run across that very much. Probably not. All right, folks, great job. You have a wonderful evening, and I will see you in class tomorrow.